Welcome to the Gresty Academy 7 must-know college entrance exam questions on cardioids and polar graphs. Now, the cardioid is probably the most famous polar graph because it's shaped like a heart, and basically the equation of a cardioid is a plus b cos theta, r equals, or r equals a plus b sine theta, where the modulus of a and the modulus of b are the same, and that's what gives it its specific shape. We can identify cardioids using our trig all stations to crew, where we can see that the sign of sine is positive, positive here, negative, negative here. So sine is symmetrical across the y-axis, and cos we have is positive, positive, negative, negative, and so therefore the cos sign is symmetrical across the x-axis, and we can use that to help us find the equation. So let's have a look at this one here first. Okay, so we know that it's going to be r equals a plus b sine or cos. We actually know that it's going to be sine because it is symmetrical about the y-axis, so we know that it's going to be r equals something plus something sine theta. And how do we find what the something is? Well, it's half of the height. So if we look at the height, it's 1, 2, 3, 4. And so basically the r is going to be 2 plus 2 sine theta. And you'll notice that this 2 here is also the point where it crosses this x-axis here and where it crosses the x-axis here. So the answer to this one is r equals 2 plus 2 sine theta. Okay, let's have a look at one slightly more complicated. Okay, question 2, what's the polar equation of this cardioid? Well, as it is symmetrical this way, we know that it must be cos, and because most of the graph is in the left-hand side of the y-axis, we know it's minus cos. If it was plus cos, most of the graph would be in this side here. So therefore, we know that it's going to be r equals something minus something cos theta. And how do we find out what the something is? Well, what we do is we add up 1, 2, 3, 4, 5, 6. So the height is 6. So it would be 3 minus 3 cos theta. And again, we notice that it crosses here at exactly the 3 and the 3. So the equation of this one is 3 minus 3 cos theta. Okay, let's move on to question 3. What's the polar equation of this cardioid? Okay, again, we see symmetry across the x-axis. And as it's mainly to the south of the x-axis, we know that it's going to be r equals something minus something cos sine, sorry, my apologies, sine theta. So we know it's going to be something minus something sine theta because most of it's down there and it is symmetrical about the y. As the length is 1, 2, 3, 4, we know that this is going to be 2 minus 2 sine theta, and again we can see that it crosses at this point 2 and this point 2. So far, so good. Right, let's move to question 4. Now, this is where it gets a little bit more complicated, is when we start looking at domains. So we can see symmetry in y of this graph here. So we know, and we now know, it's 1, 2, 3, 4, 5, 6. We can confirm that this is 3 plus 3 sine theta, but they only want us to sketch the portion between theta equals 0 and pi. Okay, so when theta equals 0, we have r is 3 add 3 sine 0, well sine 0 is 0, so that equals 3. And when theta equals pi, we have r is equal to 3 add 3 sine pi, well sine of pi is 0 as well, which also equals 3. So we know that it starts here, and we know that it finishes here for this portion, but which bit of the curve is it? Well, to do that, we have to find a point in the middle. Let's say, for example, theta equals pi over 2, and let's see what r would be equal to there. It would be 3 add 3 sine pi over 2, which is equal to 6. So clearly, when theta is pi over 2, i.e. this bit, it is here. That would be pi over 6. So therefore, we know that the portion of the cardioid we need to sketch starts here, moves around here like this, and goes around to there. And that is the portion of the cardioid between 0 and pi. Okay, now let's have a look at question 5. And just remember this because it's going to be, you're going to see something quite interesting. This looks to be identical and yet this curve is r equals minus 3 add 3 sine theta, and the previous curve was r equals 3 add 3 sine theta. And in actual fact, r equals minus 3 add 3 sine theta and r equals 3 add 3 sine theta map exactly the same cardioid, but for different values of theta, they map different parts of it, so we have to be a little bit careful. Okay, so let's put here theta equals 0. Well, this time we get r equals minus 3 add 3 sine of 0, which equals minus 3. And when theta is equal to pi, we get r is minus 3 add 3 sine pi, which again is equal to minus 3. So let's have a look. When theta is 0, i.e. pointing that way, we have the radius is minus 3, which means we have to go the opposite direction, 1, 2, 3. So this now is our start point, theta equals 0, r equals minus 3. And when theta is equal to pi, i.e. when theta is going this way, r is again minus 3, which means r is 3 this way, 1, 2, 3. So this time it finishes here at theta equals pi, and we need to know which way it goes round. So let's have a look at theta is equal to pi over 2. Well, when theta is pi over 2, r is equal to minus 3 add 3 sine pi over 2, which equals 0. So when theta is pi over 2, i.e. that way, we know that r is 0, so it goes through that point, and therefore, finally, we know that this portion of the cardioid for this domain of theta is this bit, which is exactly the opposite bit of the bit that we just shaded in previously. Okay, that one's question number 5. Question number 6, let's have a look at question number 6. We sketch the portion of that cardioid between pi over 4 and pi over 2. So, okay, well, let's have a look at theta equals pi over 4. R is minus 2 sine pi over 4, which equals minus 2 minus root 2, which is less than 0. And when theta is equal to pi over 2, we have r is equal to minus 2 sine pi over 2, which equals minus 2, which is minus 4, which again is less than 0. So now theta is pi over 4, which is that direction. R is minus 2 minus root 2, which is less than 0, which means that it starts, and I've got to get the right one here, it starts this way. This one is the minus direction of pi over 4, so it starts here. That's where it starts, at pi over 4. And it finishes when theta is pi over 2. Well, when theta is pi over 2, it's going that way, but r is minus, which means it goes that way. So it finishes here. There is the finish at theta is equal to pi over 2. And so therefore the portion is that bit of the curve there. And that's question 6. Finally, let's have a look at question 7. What is the polar equation of this cardioid? Okay, well, this one is interesting because it's been rotated. And we can either say that it is, and I'm going to draw these probably quite badly here, it's either this one here, rotated by 45 clockwise, or, I'm probably going to draw this one badly as well. Let's have a look. This one here, rotated clockwise by 45. So basically we can have two equations of this. So either r is equal to 2 add 2 sine theta rotated pi over 4 that way, or r is equal to 2 minus 2 cos theta rotated 45 degree or pi over 4 that way. And how do we rotate by pi over 4? Well, basically all we do is adjust theta by pi over 4. So if we adjust this one anti-clockwise, then we have r is equal to 2 add 2 sine theta minus pi over 4. That is the equation of that brown thing because it's been rotated anti-clockwise by pi over 4. And if it was the other one, then it would be r is equal to 2 minus 2 cos theta add pi over 4. And that would basically be this one rotated by pi over 4, and either way, let's just get rid of all of this rubbish here, either way you end up with this brown cardioid there, just got rid of that little bit of the stuff there. You get rid of the brown cardioid there. It actually has those two equations there. Okay, well, I hope you found that useful. If you did, please like this video and subscribe to the Gresty Academy YouTube channel for many more college entrance exams. Okay, bye-bye.